In this video, I will go through analysis of 4 different functions to test for time invariance. The first 3 will not be time invariant and the third one is. Let's start with the first example. The function is y of t is equal to t times x of t minus 3. So first we let our input equal, called x1. x1 of t is going to be a time-delayed version of x. So x1 of t is going to equal x of t minus some number t naught. Then the output due to that input, y1 of t, is equal to t times x1 of t minus 3. And then doing the substitution, up here where there was a t, I'm going to replace t with t minus 3. So t times x of t minus 3, oops, sorry, minus t naught, close parentheses. Alright, and obviously you can remove this parentheses without any loss. But now what happens when you delay the output? Let's make a new output, y2 of t, define that to be a delayed version of y of t. So it's y of t minus t naught. In that case, when I delay the output, I take everything, each value of t in the output, and replace it with t minus t naught. So that becomes now t minus t naught times x of t minus t naught minus 3. Alright, and I have this extra term here that's multiplying x, so it is not time invariant, and I'll abbreviate that t I. Alright, so the second example is going to be one that gives students a lot of difficulties. Y of t is equal to x of minus t. Alright, so we're going to go through the same process again. We're going to let x1 of t equal x of t minus t naught. Delay my input. Okay. What does y1 do to that? y1 of t is equal to x1 of minus t. Well, in x1 the only t is there, so that is equal to x of negative t minus t naught. Whereas if I delay the output, define that as y2 of t is equal to y of t minus t naught. Now I look back at the original signal, go back up here a little bit, and I say, okay, there's the t in my output. I have to replace that with t minus t naught. So that becomes x of negative the quantity t minus t naught, which when you distribute that minus sign becomes x of minus t plus t naught. And if you go back and compare that, that is not the same. And then, as we talked about in class, you can think about this graphically. Move over here. That if we have our original signal here, time, let's just make it a little box, goes out to 2. This is x of t. X of t minus t naught will be that same function shifted over. So from 0 to 2 it would be from t naught to t naught plus 2. The output due to this x is the negative of it, time reversible rather, so it's going to look like that. This would be y of t. The time reversal of this, though, is going to be what? It's going to be flipped. Everywhere it was positive, now it's negative. So instead of going from t naught to t naught plus 2, it's going to go from minus t naught minus 2 to minus t naught. Whereas if I delay this one, and look at this is going to negative 2, if I delay this, it will be move this down a little bit. Y of t minus t naught will be negative 2 plus t naught. 2, 0 would be just positive t naught. Alright, and these are clearly not the same. So, I'm going to pause for a sec here. Alright, so our third function that we'll consider is y of t equal x of 2t. So again, this is not time invariant because we're scaling t by 2. So let's see what happens here. We're going to let x1 of t equal x of t minus t naught. And we put that through the system. We have y1 of t is going to equal x1 of 2t. Well, where is t up here? It's right there. So that's what gets replaced with 2t. So that equals x of 2t minus t naught. On the other hand, if we consider y2 of t equal to y of t minus t naught, then we are going, again, putting that back in is equal to x of 2 times t minus t naught. Again, we're substituting in for t for x up in the input. See, we're replacing this with t minus t naught in this case. And now when we distribute it out, we end up with x of 2t, but now we have minus 2t naught also, instead of just 1t naught. So that, again, is just not time invariant. And again, if you look at this example where you're scaling, or the previous example where there was a minus sign in front of the t, and the first example where there was a t out front, those are all hints that it's not going to be time invariant. So now let's look at an example where the signal is time invariant. Excuse me. So we have our fourth example is y of t equals x of t squared. Alright, so now when we let x1 of t equal x of t minus t naught, y1 of t is equal to x1 of t squared, which is going to equal x of t minus t naught squared. And again, this squaring is just squaring the amplitudes. Now if we look at y2 of t equal to y of t minus t naught, we get x of t minus t naught, the quantity squared. And since these are equal, is time invariant. Alright, so that's it. Thank you.